and welcome to my YouTube channel. This is my first video ever. So today we'll be doing Leetcode problem number 13, Roman to integer. I will be doing this in JavaScript, Ruby, and Python. All right, so let's read the question. So Roman numerals are represented by 7 different symbols: I, V, X, L, C, D, and M. So the symbol I represents the value 1, V represents the value 5, X represents the value 10, L represents the value 50, C represents the value 100, D represents the value 500, and finally M represents the value 1000. Okay, so for example, 2 is written as II. So that will just be 1 plus 1, which becomes 2. Just 2 ones added together. Yep, makes sense. 12 is written as xii, which would be what? X represents 10, plus I, which is 1, plus I, which is 1, becomes 12, which is simply 10 plus 2, which is 12. Makes sense. The number 27 is written as xxvii, which is xx, which is 20, plus v, which is 5, plus the 2 i's, which is 2, becomes 27. Makes sense. Let's continue. Roman numerals are usually written largest to smallest from left to right. However, the numeral for 4 is not I. So that is invalid. We can't have 4 of them in a row. So instead, the number 4 is written as IV. Okay, but over here it says Roman numerals are usually written largest to smallest from left to right. Well, in this case, that is not the case. This is smaller than the next one. So that's just something to keep in mind. Because the 1 is before the 5, we subtract it, making 4. The same principle applies to the number 9, which is written as IX. So basically, our current value, which represents 1, is smaller than our next value, which represents 5. So therefore, we have to subtract it to get the value for the Roman numeral, which would be 4, because it'll be 5 minus 1 becomes 4. Same thing in this case, x represents 10, so 10 minus 1 becomes 9. Okay, so there are 6 instances where subtraction is used. I can be placed before v and x to make 4 and 9 respectively. X can be placed before L, so L represents 50, so if you had XL, that would be 50 minus 10, which becomes 40. And then if we had XC, C represents 100, so it'll be 100 minus 10, which becomes 90. And then C can be placed before D. D represents 500, so if we had CD, that would be 500 minus 100, which will make 400. And then if we had CM, M represents 1000, right? So minus 100, that becomes 900. So given a Roman numeral, convert it to an integer. Okay, so let's look at the examples. So example 1, we have the input string s is equal to I. Very straightforward. It's in standard Roman numeral format from largest to smallest. We just add them up, and our output is 3 because 1 plus 1 plus 1 is 3. Let's look at example 2. In example 2, we have the input string s is equal to LVII. Okay, the L represents 50, the V represents 5, the I represents 1, 1, and 1, so when we add it up, that becomes 58. Pretty straightforward. Let's look at example 3. In example 3, we have the input string s is equal to MCMXCIV. Our output is 1994. Let's see how. The M represents 1000, okay, and that's standard format because the next character is smaller. And then we look at the next two, CM represents 900. That's because since C is smaller than the next character, which is M, we have to evaluate them together. So the CM becomes 900. Similarly for XC, which becomes 90, and IV, which becomes 4. So when we add all of them up, we get 1994. Okay, let's check out the constraints. So the constraints say that s.length is inclusive within the range 1 to 15. So we're guaranteed to get at least one Roman numeral. That makes our life easier. Very good. S contains only the characters I, V, X, L, C, D, and M, which means that it is guaranteed that S is a valid Roman numeral in the range between 1 to 3,999. Okay, that makes our life very easy. Okay, so let's actually pseudocode this out, and then we can start coding this out. Okay, first of all, I will turn this into ES6 syntax because I think that is better. Const Roman to int equals takes in S. We're going to give it a fat arrow. There we go. Sorry about the console log. Alrighty, let's pseudocode this out. So first off, we will need a legend of some sort, right, to key into to get the value for each Roman numeral. So make a legend with Roman numeral as key and its value as a value. Okay. Next, we should initialize a sum variable to add to and to return at the end. Okay, I'm gonna do that next line here. Return sum, just so I don't forget. Okay, so now we want to iterate over s over input string s. Okay, if value for current Roman numeral is less than next Roman, I'll just leave that as Roman. If that is the case, we want to do add the difference to our sum. So basically, next minus current. And if we do that, we are looking at the next value. So we would have to increment I as well. Else, we know that our current value is in standard Roman numeral format, which is the largest to smallest from left to right. We can just add the current value. Okay. So looking at this approach, we are iterating over the input string s one time, and that's all I see. So our time complexity will be O of n, where n is the length of our input string s, and our space complexity, let's look over here. We are just making a legend, and pretty much that's it for space, and that's constant. That will always remain 7, right? There's only 7 values in here. 1, 2, 3, 4, 5, 6, 7. Yep. So that will be constant as well. That is not dependent on the size of our input. That will be O of 1. All right, great. Let's code this out. So const legend equal to an object where I, the key I goes to the value 1. B represents 5. X represents 10. L represents, what is out, 50. And then we have C, which represents 100. And then we have D, which represents 500. And finally, M, which represents 1000. Great. Let's initialize our sum variable. So we will say let me put this here because there's not that much space. Let sum equal 0. Okay, now let's use a for loop to iterate over our input string s. So we'll say for let I equals 0, I is less than s dot length, I plus plus. Alrighty. I could do this in my if conditional, but I will break this up just so you guys can follow along. So we can say const current value is equal to legend of s of I. And then we can say const next value is equal to legend of s of I plus 1. Very good. Now we hit our if conditional. If current value is less than next value, what do we want to do? Whoa, whoa, whoa. That's the case, right? We want to add to our sum plus equals next value minus current value. And also, since we looked at the next value, we want to skip it. So we will say I plus plus. Else, we know it's in standard format, and we can just add the current value to our sum. Very good. And then after our for loop, we should return our sum. And before I run this, let me walk you through a test case. So let's do this test case right here. Yeah. So we have the input string s is equal to mcm_xciv, right? Let me initialize my other variables and comments. We have our sum, which is equal to 0. And then just for simplicity's sake, we can say s.length is equal to how many we got? 1, 2, 3, 4, 5, 6, 7. Right? 1, 2, 3, and then plus a 4. Yep, 7. You also initialize current value and comments and next value and comments as well. Okay. I am missing one thing. We can say I, so we can keep track of the iteration. Okay, so let's go through our code, right? So we have our legend. Sum is equal to 0. Yep, sum is equal to 0. For let I is equal to 0, I is less than s.length, so 0 is less than 7. So now we hit line 28. Current value is equal to legend of s of I. So what is s of 0? S of 0 is the m, which is on index 0, right? So we key into legend with the key of m. So m points to the value 1000. So we can say current value is 1000. Next value would be legend of s of I plus 1. S of I plus 1 will give us the c because index is 0. 0 plus 1 is 1. So s of 1 is the c. And then we key into legend with c. We get 100. So our next value is 100. So we hit our if conditional. If current value, which is 1000, is less than 100, which it is not. So we don't even look at this code. So we go into else, sum plus equals current value. So sum becomes 1000. Okay. And then we end that iteration. Go back to line 27, I plus plus, I becomes 1. All right, let's update our current value. We already know our current value of legend of s of 1 is 100 because it is a c. And then next value, legend of s of I plus 1. 1 plus 1 is 2, so s of 2 is m, which is at index 2 in this input string s. So we say, what is legend of m? We already know that is 1000. So now we hit our if condition on line 30. If 1000 is less than 100, which it is, we'll do sum plus equals next value, which is, oh, I'm sorry. I am so sorry. We have our current value is 100 and our next value is 1000. I am mistaken. Current value is legend of s of I, which is 1, so legend of s of 1, right, which is a c, legend of c is 100, and legend of m over here, which is the next value, is 1000. Okay, so now we're saying if current value, which is 100, is less than our next value, 1000, which it is true, we'll do sum plus equals next value, 1000, minus current value, 100. So that becomes 900. We add it to our sum, which becomes 1900. And then we do I plus plus, so I becomes 2. And then we finish that iteration. Then we go back to I plus plus, so I becomes 3. Okay, so current value for s of I is 3, so s of 3, 0, 1, 2, 3 is the x. So legend of x is 10. And then the next value, which is a c, which represents 100, because legend of c is 100. And then we say if current value, which 10 is less than 100, which it is, we will do next value 100 minus 10, right, which is our current value, becomes 90, and then we add that to our sum. So we get 1990, and then we increment I becomes 4. We finish that iteration, hit line 27 again, I plus plus, I becomes 5. Now, current value of legend of s of 5, so 0, 1, 2, 3, 4, 5, which is the I, we already know that represents 1. And then s of I plus 1, so 5 plus 1 is 6, so 0, 1, 2, 3, 4, 5, 6, which is a V. We know legend of V gives us 5. Over here we say if current value, which is 1, is less than 5, which it is, so we'll do sum plus equals 5 minus 1, which is 4, will become 1994. Very good. I plus plus, I becomes 6. Then we hit line 27, I plus plus again, I becomes 7. And then we check that conditional. Is 7 less than 7? It is not. We exit our for loop, and then we return our sum, which is 1994. So it should work. So let's run the code and test this out. Very good. It passed the first test case. Let's submit it. Awesome. Passed, and it was accepted. Now let's do this in a different language. Should we do Python or Ruby first? Let's go with Ruby, because that was my first coding language. Okay, so same principle, right? We're gonna need our legend. Ready? I won't do no pseudocode or no walkthrough for this one. It's pretty much the same thing. Okay, so we have I. So in Ruby, we have to use fat arrow. I goes to 1, V goes to here. Let me put it back to the description so you guys can see. B goes to 5. X. Well, be careful with the syntax now. Goes to 10. L goes to 50. C goes to 100. D represents 500. M goes to 1000. Great. So we have our legend. Now let's continue. Let's set up our sum is equal to 0. Let's also, this time I'll use a while loop. I'll use a while loop this time. So let's start with I equal to 0. And then we're going to say while I is less than s dot length. Right? We're also, in Ruby, we have to end it. So we'll do that here. So we have our while loop. We can do current is equal to legend of s of I next. Okay, that is a keyword in Ruby, so we can't do that. So I'll do next is equal to legend of s of I plus 1. Okay. Some have a different conditional since we're using a while loop, right? And we're going to be comparing next, and it might not exist, and this is not JavaScript. And since I'm setting this up a little bit different, so I already know beforehand if we hit the end, right, and we key into legend, it is going to give us nil. So I'm going to say if nxt is nil, I want to do sum plus equals current. Okay. Else, if current is less than next, right? If current is less than next, then we want to do sum minus equals. We're going to do a different way. Minus equals current. Else sum plus equals current. So this is just another way to do it. Yeah, let's end this and then let's return our sum. We can just say sum and it will return it. We don't have to say return sum in Ruby. So yeah, that's how to solve it in Ruby. Let's run this. Oh, I forgot something. This is an endless loop. Forgot to increment I. We will do that right here. We can do I plus equals 1. So you have to, that's why I like to walk through an example just in case if I forget something like I just did. So let's run the code. Very good. Let's submit it. Awesome. fast. And now let's do this in Python. Python 3. Go back to the description. All right, for Python, what am I thinking? We're gonna still need the legend. All right, so let's set that up. Python's a little weird where you have to be careful with your indentation or else the code will not run. It will mess up. So we have to be careful over here. So yeah, let's say legend is equal to an object, right? Where I represents 1. I'm just gonna copy this over so I don't have to keep doing that. Okay, much easier. 3 to 5, x to 10, L to 50, C to 100, D to 500, and finally M, which goes to 1000. Okay, I have my legend. Now let's continue. We do need our sum or total. Let's call it total this time. Equal to 0. And let's also use a while loop. So I is equal to 0. All right, let's do this a little bit different this time. Yeah, so while I is less than length of s, we're gonna say if. So in Python, right, it will error out when it tries to find the last one because we're gonna do I plus 1 and try to key into that. So I'm gonna take care of that right now. I plus 1, right, is less, if I plus 1 is less than the length of s, and legend of s of I, right, legend of s of I is less than legend of s of I plus 1, colon. So if that is the case, we can do total. Let's just do it the way that I did in the first example, so you guys can see both ways. So legend of s of I plus 1 minus legend of s of I. Right? So take the next minus the current, add it to our total. But since we looked at both, we want to increment I by 2. So I plus equals 2. So if that is the case, we'll do that. Else, what do we want to do? We just want to add the current to our total. So we'll do total plus equals legend s of I. And we will do I plus equals 1 to go on to the next character. Okay, so after we exit our while loop, we want to return our total. Let me just make sure everything's good. Yep, increment I by 2 if we look at the next and use it. Otherwise, it's increment by 1. Yeah, very good. That should work. Let's run the code. Very good. Let's submit it. Awesome. So yeah, so we solved Roman to integer in 3 different programming languages in Python, right? We could do it like this, or another way we could do it. Let me just show you. We can just take this off, take this off. either case, we will do I plus equals 1. And yep, we'll do total minus equals the current. If you do the math, it will still equal out the same. So let's submit that. Very good. That passes. Let's go back to Ruby. Okay. So for Ruby, let's do it a different way. Okay. So let's do it the same way we did it with Python, right? In case you didn't know about this. So I'm gonna get rid of the while loop. Well, I need the while loop, so I'm gonna get rid of these if conditionals. Okay. So while I is less than s dot length, we can say if I plus 1, right, is less than s dot length and legend of s of I is less than legend of s of I plus 1. Okay, if that is the case, we want to do total minus equals legend of s of I. Alrighty, else total plus equals legend of s of I, or our current value. And either case, we'll be incrementing I by 1 because we are never looking and using. We are never using the next value. We are looking at it, but we aren't using it. So we don't need to increment twice. So we just increment once, and that should work. And we return the sum at the end. That should work. Let's submit it. Oh, I forgot to end for if else. See, this is what happens when you rush. That's why it's always good to look at your code. Okay, what's the problem here? Total plus equals undefined method. Oh, we called it sum. My fault, guys. My fault. So just kept his sum in the Python one as well. That got me confused. Okay, here we go. Sum, yes. Submit. Time limit exceeded. Okay, what's going on now? Oh, this should be underneath. See what is going on? If, else, and. Okay, over here, I plus equals 1. That is outsider conditional. Submit. See, there we go. My fault, guys. It is like almost 11 p.m. 11:30. I'm sorry, 11:30. Like it's past my bedtime. Yeah. Okay. So yeah, we solved Roman to integer in Ruby, Python, and JavaScript. So here's a Ruby code. Let's go to JavaScript so you guys can see that one. Alrighty. All right, we have our legend. For this, we don't have to check at the end of the string because over here, right? If current value is less than next value, right? Let's say we're at the end of the string and our input is I. Our current value is I, right? Which represents 1. Next value will be undefined. Undefined. So if 1 is less than undefined, it will never hit that case in JavaScript. So we just hit the else state and we will just add the last number value of the Roman integer to our sum and return it. Yeah, thank you for tuning in, guys. Hope to see you guys soon. We'll solve a more challenging problem next time. Thank you very much.